All right, perfect. Hopefully my computer won't crap out this time. That was me debugging it or trying to fix my computer for 20 minutes. So that's fun. But for the people who are listening, hey, welcome back. We're going to be talking about Unity Scriptable Objects. Why? Because they're cool, and you might find a use for them. So, good morning as always. Here's the outline. Some of you might have recognized it if you were here. Thank you. So, what is a scriptable object? Well, it's pretty simple. It's an object that can be scripted. What does that mean? Let's actually use some more technical terms. So first off, link to documentation. I'll have the slides posted so you can view those at your leisure. But Unity's scriptable object class is, well, a class made to hold data and also be scripted. So a scriptable object. Pretty simple. Scriptable objects themselves are stored as files in your Unity project. And because of that, they will be shared. But they do have the capability to be instanced, to create clones of them, which are your instance, and et cetera, et cetera. And that's pretty cool. Why? Because that's kind of what the factory design pattern is all about. You have your one base object, and you create a bunch of clones out of it. The scriptable object class itself has the create instance function, which allows you to create an instance of the base class with the default values. Sometimes useful if you're not doing something like what we're going to be touching upon later today. I'll bring up some examples probably as we look at the code later. But what works well in a lot of cases is the instantiate one, which actually clones the scriptable object to create a bunch of instances, and that's pretty cool, as you'll see. So, of course, you have this piece of data. It's shared. And because of that, it comes with a lot of requirements that you're going to have to watch out for as you're using them. One such requirement is, well, they're files. They're Unity's proprietary objects and all that, which means they're managed by Unity. And you know what that means? C# does not care. Now if something's always referencing it, it will never get rid of it. And that's a problem if you're creating a lot of instances, nulling all your references to them, and forgetting to destroy them. So yeah, that's something that you're going to have to watch out for, because since Unity is always holding a reference, you have to destroy your instances when you are destroying your object. I'll show a bit of that later. I just realized I'm not actually doing that, and I need to fix that in my code. And yeah. And as mentioned, you might also be holding to the actual asset that's in the your project directory. So you also want to be careful. I believe that Unity does not allow you to do that though. So if you for example, call destroy on a reference to a prefab in your file explorer or project folder, sorry, it will say, hey, you tried deleting something that you probably weren't trying to do. It's the same for the scriptable objects most likely. I have not tested it. We can test it later. So, another thing, shared instances. Well, guess what? If you're editing the values in your pointer to the shared instance, it's editing it for everyone. That might be what you're looking for. That is very helpful for, one example would be like an enemy an enemy manager. So you have your one instance of scriptable object in your project folder that's managing the difficulty of your enemies. And each time you increase the wave, you can hold a reference to that object, change it, and all your enemies, if they all have a reference to that same object in your file structure, they'll be able to find it. A lot easier to manage than a static variable, and you can even edit it in the inspector while it's in runtime. Good thing to note, if I remember correctly, if you edit it while in the Unity editor, it will not revert after you exit play mode. But if you edit it in a build, it should revert, I believe. I don't remember what happened in my testing. It's a very finicky place. That's why if you are editing the data, be sure of what you're doing, and most likely you want to be working with instances. And of course, these are data. You can write functions if you want, but you still need to call them, but it's main purpose is to hold data. So
it's very good if you want to have something that your designers can edit without messing with scene files, so that you get less git merge conflicts.
yeah, it's data. And it's cool, but that also means that all the classes that are interfacing with these have to, well, pull out the data and do something with it. Again, I have an example. And to show that example, I'm going to talk about it. So, I've talked about this project many times because I threw in all sorts of cool concepts in it, so I'm going to use it again. Table Fable, the game I made. It stored all the cards as scriptable objects. You might have seen it when we talked about editor scripts, but let's talk about the actual scriptable object part now. I used inheritance to provide more capabilities. We had the base card class as a scriptable object, and all the children. One thing I did not do here was create instances. Instead, I just cached all the health and attack inside the object. Not a good idea. Don't do what I did. It was very stupid. I wish I understood how to instance scriptable objects. And we'll be touching on that later. And also, yeah, editor scripts, you can make them work with scriptable objects, which are really cool. You can make the automation things that we discussed last time, or just use it to pretty it up. So, why did I use scriptable objects and not just, for example, have a prefab for every card? Well, it was easier to work with. Working with prefabs, you'd actually have to scroll to the component to edit all the data. And I'd also be throwing all the data with the card class itself, which already had a lot of member variables, and it would get messy really quickly. And because of that, we can separate all the core card data in a scriptable object class called card, while all the card management system can be handled by the card component. And that helps make things a lot more organized. It also meant we can easily disable rendering by just not loading the data. And instead of having to load some default data somewhere else, we just don't do it. It works out decently well. You could do it with everything being in a single class, but scriptable objects did make that slightly more easy to come up with, you could say. Because working with scriptable objects does change your workflow. So do keep that in mind. Retrofitting this kind of stuff, not very fun. And also, we had a lot of cards. Every time we wanted to change how the systems work, we only had to change a scriptable object, and then the card class would just deal with the functions we wrote. And that made for a lot easier expansions whenever we updated the game with new features. So, you can see here in our project folder, I actually have a thing called cards, and here's all the cards. So how we created cards was when you create a scriptable object, you will normally create this menu thing where you can allow yourself to, well, initialize your scriptable objects. If I actually open up the script, there it is. Card stuff. Oh, card stuff. Card. This was my base class, and it's on my left monitor. As you see here, oh wait, no, that's not the card. Card data is my scriptable object. Naming schemes. Do better than what I did, please. So yeah, this is a scriptable object. You can see the card one, there's nothing on top, but if I, for example, open monster data, I created the asset menu. That made it easy to make sure that the base class, which is normally something you don't want your designers, I guess, to be using, you can make sure they don't accidentally create one, because it might just be there for the actual base class like I have here. It's something simple, but yeah. You can set the default file name, where it is in the menu, and its order. That's all simple enough. We kind of talked about that beforehand. But you can see you can't actually find these at the top of here. Instead, they'll just kind of appear in the list. Now, obviously, that's where you might need a editor script if, for example, your base class has private properties. So do keep that in mind. It does get messy if you have a big inheritance tree. Bilal was right in that inheritance is bad sometimes, but not always. So I'm gonna keep using it. So yeah. So this is an example of how we have used scriptable objects to make the management of data a lot easier. We could also add stuff like the check cost function, which avoided bloat in the card class, which was already pretty bloated at 131 lines just for the base class itself, and then you start adding the 400 lines of the monster card class, and then the monstrous spell card. Never mind, spell card class only 150. This is the one that's monstrous because I added all my functions here. There's a lot of things I would have changed with how I wrote this project, but hey, we always learn as we go. All right, so yeah, that's kind of what I wanted to gush about using. It's an example that you could do, and it made our workflow a lot easier. It made everything a lot more organized so that we can actually find where everything is and not have to deal with a bajillion prefabs because you already have a lot. Does also mean you're saving space because you're not saving entire prefabs or prefab variants, I guess it would be. All right. But that's enough of that. Let's actually do something live. Minecraft. So, this is a project I quickly threw together for today, and it's pretty simple. It's using scriptable objects to create Minecraft-styled items. So if Unity would just start. There you go, perfect. So you can see here, it's the Minecraft hotbar. You can scroll to select the item, and if I press E, it's going to do nothing because I'm hovering over nothing. If I hover over a sword, you can see it prints out the name and the amount. So, food, I made it so that when I press E, it's consumed. So that's showing that inheritance works. So what are some cool features that I have set up? Well, you can drag and drop, and they will stack properly. You can't stack different items. You can hold right click to split, and yeah, it's the Minecraft styled thing. Oh, and if I press E there, you can see it says sword 2. It is dynamic, and yeah, that's a very this is a very simple thing. Let's look at the workflow that you would have to do if you were working with this project. So to create new items, you would go to your item folder, and then right click. Create item, and then the type of item you want to make. In my case, I have consumables and inventory items. They're fairly self-explanatory. Let's look at the actual scripts they have. I'll share all the code later so that if anyone wants to explore this project, they can. So this is the item. You can see the base class, I actually decided to make it public. Why? Because sometimes you just need an item that just exists. Doesn't do anything on interact besides print its name. You can see right here. But it works. So what does it do? Well, or what's important? Well, this clone function. I brought up the factory example before. And you want a way to, well, create some clones of your object. Well, here you go. Here's how you do it. So the item itself, you will create a copy, which means copying all the data inside of it, which is better than creating instances by using the instantiate function that's built into Unity against the object itself. And this will allow you to create a clone. I have this isInstance bool so I can check if I'm actually working with instances to avoid editing the main object. So that if I actually go here, it's right here. So that's something that you might want to consider. And I'm also getting rid of the name because I was using the name in my thing. If you don't care, you don't need to do this, but this is just getting rid of the parentheses clone that you always see getting added automatically to your objects. So from here, we have stuff like the onInteract function, which is virtual, and then the standard Minecraft stuff that you saw, the splitting when you hold right click, make sure that you can actually do it, and the stacking. I have a lot of weird stuff with how I'm managing the items, so I don't exactly recommend what I did, but I'll talk about some interesting things to note in the stacking. So what you're doing is you're stacking the other on top of the current one. I'm using compare to with the name because like I said, I'm using the name, but I'm also using get type. Now this is a C# function. What it does is return the class type itself. Why is that helpful? It returns the actual class type. So even if the pointer is of type inventory item, get type will actually return any children classes, which is really helpful because it makes it so that you avoid, like for example, stacking the wrong things on top of each other, or even just knowing if something's a child class versus the base class. And, you know, that's always good to consider when you're trying to optimize how you're doing your comparisons, not needing excess variables and all that. Now, of course, we're stacking, so what we need to do is add the count of the other to the current one, check if it's above max count, and if it is, then you have to do. Then if it is, then you can return other because other is overflowing. Otherwise, we're combining two items into one, which means we need to kill off the other one, and that's where I was not able to just do other is equal to null. I had to make sure I destroy other, and how I wrote the code was a little jank, so I had to also return null. So that's an example of how you would use this for like combining things and make sure you're managing your memory by calling destroy. Now this thing I mentioned about, whoops, I forgot to do. Well, over here I have this thing called the inventory item watcher. When you destroy this object, it never destroys the reference it's holding to the instance, because this is what's holding all the inventory items. And there you go. You can see I'm holding it in a reference. Oh, and this is a random fun fact. If you use a question mark before a function call in Unity, it performs a null check. So if your function, or if the object on the left doesn't exist, it will just not call the function and just return the default value of whatever the function does. So if it's void, it literally does nothing. In my case, onInteract returns a pointer to an inventory object. If reference is null, it'll just return null. Otherwise, it'll call the function. So this just streamlines the code. It's a little nicer than having to write if reference is not null, then doing all that stuff. And yeah. And this is some code that you can look into if you want. It's just doing the Minecraft stuff. One thing we're going to do now is create a new item type to kind of show how the workflow is. So we're going to make a, what do we want to do? We'll make a spawn item. Sure. And what it's going to do is going to spawn something. So we're going to just game object spawnable public override, and no, my control Z doesn't work on that keyboard. Public override on, oh wait, I forgot to override the class. One thing that you might have, I'm using a random snippets extension, but if you type scriptable object, if you have these like snippet extensions, it can automatically set yourself up to have this, which is really helpful. I find it really helpful, at least. And from here, I can now do public override. Oh wait, I forgot to change the base class again. Whoops. Inventory item, and now public override. Now we can find the onInteract. Thank you, IntelliSense. I'm not going to call the base class, so okay. Now let's think. This is a spawn item. What do we want to do? Well, first off, I had the thing, but it got rid of it, so let's re-add that back. We had a public game object spawnable. And then in the onInteract, we need to return something. So we're going to return this by default, because that's what it should be doing. Oh, I forgot. My snippet duplicates that for some reason. All right, so onInteract. We want to spawn the spawnable. So we will just instantiate spawnable. We don't care about anything else. We're just going to do that for now. If you want to make your system more complex, make onInteract take in the player controller, for example. That way you can get like the player's forward, its position, etc., etc. Also, it's 8:54. I don't know if you have to head out.
There is another bus at 9:30, so I'll just go on that.
All right. If that's okay with you. So yeah, this does the spawnable. Now, it's not going to consume the item. If we actually go to my consume item class, I forgot I can actually just use my OBS to look at my screen. This is my consume item code. What it does is it gets the count, and if it goes below 0, then we can destroy the item. So let's just reuse that below the instantiate. And there you go. Now we have created our spawn item. Do I have any other code in here? No, I don't. You can make it more complex. You can add more functions in the base class to override. And what's nice is you notice how I didn't have to redo the clone function. That's because C# is smart enough that this clone function that returns an inventory item and Unity instantiate function, all of these actually work with inheritance. So all your children classes, if you instantiate them and create copies, they'll be pointers of the original class, but they won't be of that class. They'll still keep their class, which is really cool. So I don't have to rewrite this clone function. It just works for every child. Okay, so we created that.
Polymorphism.
Yeah, polymorphism, let's go. Okay, so now we create a new item type. And when we check here, oh, they called it inventory. Lame. Now we're going to call this cube. Let's fix that. Right here. See that folder? We're going to call this item because I believe that's what I had. Yes, it is. Let's save this and go back to Unity. All right, and now we got our cube. You can see it's got all the base stuff here. Let's say I'm going to make it only stackable to 2. Now I can add the spawnable. So let's add a cube to the scene. Since I call it cube. Make sure it's in front of the camera. And then grab this cube. Oh, I need to make it a prefab. Now, you might have noticed I called instantiate this time without, well, anything. That way, it'll just save wherever the prefab data is stored. So if you actually look here, see the prefab? Its position is at, well, whatever that is. That's because it saves the position before you drag it into your project explorer. So that is why the position might be jank if you forget to do this. So always remember to reset the position here if you need to. But we don't need to this time. So how did my thing work? Well, let's actually talk a bit more. So if we go under my main camera, I have this class called hotbar, and that's where the hotbar thing you saw earlier was. So let's grab that cube, slap it in there. So you might have remembered I talked about, you might have remembered I talked about instances before. Well, if we go to my hotbar class, you can see we have so what I'm working right now is on the start items array, and what it does is it clones it if it is not an instance. That's where having a bool to check for instances is helpful. And I'm also checking if an item actually exists, of course. So yeah, so this is like to add safety to make sure that my item is not a clone, because I don't want to be working with a clone. Or the reference, I want to be working with a clone. Alright, so let's actually see if this worked. So if I do this, we can see our hotbar now has cube. Can't stack cube with other stuff, actually. Let's do something more interesting. Let's call this food. Oh, okay, let's put it here and then call it food. Okay, it doesn't mind that. So you might notice we have a problem now. They both have the same name, but they're different base classes. This one, yeah, see, this one's a consumable, while this one's a spawn item. But because I did that get type check, that ensures that they won't stack. So if I go in full screen, food over food, doesn't work, but this food does. Gets confusing, I know. So don't do this. It's very messy. What next steps would you take with this project? Well, one example would be, you might notice everything's kind of a black box and they're just identified by the name. You can store a reference to a texture inside your scriptable object and then apply that texture to a sprite renderer or a mesh renderer as a material, for example. Those are some ways you can get around all this. Oh, and let's check if food works. So the original food, all it did was just make the count go down. That still works. But it's a spawnable food, and what it will do is spawn the cube and consume itself. So I can't, so pressing E does not do anything. I can prove that by showing the hierarchy. There's only one cube clone. And there you go. That is a modular kind of Minecraft inventory item. Again, I'll be showing you the code if you want to look at this. And it's using scriptable objects in a way that makes creating new items very easy, because all you have to do is create a new scriptable object, assign all the data in there, and all you're doing is just storing that scriptable object itself, not having to deal with prefabs and prefab variants and changing around the components and all that. And you would be working with prefab variants because you want to make sure all the base class stuff gets traveled through, but it gets really messy. Doing it like this, a lot smoother, a lot easier to do, and makes it very expandable if ever you have a future change you want to do. Some other cool things that I would do as next step for this project, well, we have these scriptable objects things. We have a way to compare them, as you saw wherever that was. I believe it was here, in the tri-stack. No, it was in the clone. It was in the, no, not clone. Right here, yeah, in the stack function. You can see right here, we can do get type, which means you can actually check if an item, for example, in a crafting grid, matches by, rather than holding instances, you can hold a reference to that base scriptable object, which it can be a shared thing because you're not going to be editing it, you're using it as read-only. And because of that, you have a lot smoother of a workflow for creating like crafting and all that, and making it very easy to modularize by just throwing in all your things in order. And it also avoids making your code a real mess with prefab pointers and like other ways of checking data. It's all built into whatever class you write. You can also overwrite the equals parameter to make it deal with all this like junk. One thing I do is I have a virtual override get type in all my child classes, so I can get like the ID of that if you can't do other things. Those are all sorts of random ideas. Maybe we can touch on this in the after hours since we got some time. And yeah, that's kind of what I want to showcase. Hopefully that inspires you to think about how you can implement scriptable objects into your projects. And yeah. I just realized I have a weird typo in this slide. So that was my information. Now, you might not have all the ideas yet. You might still be saying, but where can I use these? Well, it is true that it really depends what you're working on for if it actually is worth implementing into your project. But it is very powerful when you're using it properly. Why? Well, there's that editor editable function. Always love that. But also because it's stored as files, so they're persistent, and you don't need to like hard code everything inside a single script that's initializing all of it. These are some links shared from our fellow exec Bilal. He also loves scriptable objects but couldn't make it today. So check these out if you're interested in more technical, more complex, and obviously, more useful discussion on the whole concept of scriptable objects. Have a good rest of your day, and goodbye. And I'll see you next time, whenever that is. I'm going to stop the recording now, and we'll figure out what we're going to do in person.